Okay, so I'm gonna go back and let's open up from a long time ago. So exam is, let's make sure we have the date right. Make sure I have the date right. Monday at 10:10. Sound accurate? All right. So Monday at 10:10 a.m. we have our final exam. I'll design it to take about an hour, like all the other exams that I'm given. So it should not be a time crunch issue. You should be able to finish it in plenty of time. Let me zoom again here. There we go. All right, so I'm going to kind of go through the slides and tell you the topics that I think are going to be important. Just like my other classes, if you do better on the final than you did on the midterm, I'll replace your final exam grade with the midterm grade. And I'll probably focus on things since the midterm till now. That'll be the primary chunk of the exam. But let's just flip through the old slides too, in case there's something that's popping up that a lot of people missed on the midterm or something like that. Then I want to make sure gets covered. I don't want to ask anything about that. I suppose an iOS versus Android question is fair. I would say it's 30% chance, not high on the list. If I were going back and searching for an extra question, I might come up with something along those lines. Certainly this idea, and this is something we've talked about since the midterm, that operating systems are effectively resource allocators. I mean, that's everything about the operating system is about managing resources. Okay. Bootstrap is fair game, but low possibility.
Could it be said now with Apple's like 3D touch screen that their OS is probably more fragmented now than it previously has been because it has a different user interface, like physical hardware user interface?
Well, I mean, I don't think that's a fragmented. You mean that some of their devices allow... Okay, I get what you're saying. You're saying that because some of their devices have the 3D touch and other ones don't, that now when somebody's designing an app, if they want to support 3D touch, we're still recent enough that they have to choose to support it in some cases versus not supporting in others.
Yeah.
Is there a common... let's see.
Because like that home screen deep press.
No, I get it. So I'm just interested in what apps support it.
There's quite a few.
Who has a iPhone 6 or older that also has the Facebook app on their phone? What happens if you press and hold on Facebook? Does it do anything? They just start shaking and deleting it? Okay. Because like on mine, it brings up like this context menu. Yeah, if I want to delete it, I have to like barely like touch the screen. Then I get
some getting used to.
Yeah, there's like the two different levels of
there's like three almost.
Yeah, so I didn't know if there was kind of a common way of handling that or not. I guess it's probably just an if statement that says if you have this. Yeah. So maybe that's not too fragmented. Because if you don't have to treat it completely different. Like an example might be some of the older, if you had an older device, iOS device that was running an older OS is the bigger issue here. You would present a window for showing email one way versus a newer device. You would present it a different way that was different than the old way. The old way wasn't compatible with the newer operating systems. That would be an example of fragmentation because now you literally have to handle both cases. Okay. Where in this one, it's just, if you have this device, I'm going to provide this feature, otherwise I won't. That's probably not it's probably fair to say it does add a level of fragmentation, but not really a problematic level of fragmentation. But certainly as we go... a year or two into having kind of the 3D touch stuff, and then you're going to obviously have the Android side. I mean, I'm sure there are already some Android devices that have something like that.
don't think I've seen it.
If there's not, there will be, right? So now it's going to become more of a common idea for interfaces. At that point, maybe fragmentation becomes a bigger deal because some apps are going to maybe rely on some of those features. Right now, it's almost gimmicky. In fact, I
actually have a video game on my phone, or a game on my phone that relies on 3D touch for control.
Yeah. Okay. Oh, I can see that maybe being interesting if it's precise enough, and I think it is because didn't they outlaw being weighing things?
Yeah. A guy made an app that's a game.
Yeah.
That has it basically has a scale built into the game. Like the game is like you move. It's like Flappy Bird, but with the deep press. So
okay.
It moves a dot up and down, and then it shows like how much pressure you're putting on, and then he just like gives you a simple equation you have to do that then gives the amount in grams.
I got you. I wonder how sensitive it is. What's the lightest?
Measured out some oregano and some flour to demonstrate it. And it works pretty well. So.
Is this your random number? Is this your random number generator, buddy?
I gotta watch that later.
Is this your random number generator, buddy?
Yeah.
That's him. Let me know if your random number generator pops out the first episodes this season of Arrow.
This season?
I got a...
Yeah, I have everything on Netflix.
I got a random number generator that has it. I can get that.
So in any case, so that's something that... Well, actually what I was getting at, and Nick's not here today, but Schumacher, I don't know if he really does it much anymore, but when I first met him, a year and a half ago or something, one of his hobbies, he has like a really accurate scale, and he would go to stores and weigh like Yu-Gi-Oh packs and stuff like that because there was a slight difference in weight between packs that had like elite, like special cards in them versus not. And it was actually a very interesting ethical discussion. I mean, it is almost an ethical computing type discussion where if you go to the grocery store, you're shopping for oranges, you inspect and try to bring home the best orange, right? Mm-hmm. So wouldn't the same thing hold true if you're going and buying a pack of cards that have a random quality in it? If you had the ability to inspect the quality of the pack of cards, that's just
makes sense
from that perspective.
It's a little bit different because I think with the pack of cards, part of it is the randomness of it. They don't show you for a reason. Oranges, they show you because they want you to.
But you don't know what's inside the orange. Just from the outside, you're making a guess.
You're right.
So in this case, it's like all oranges.
I would totally weigh the packs. I'm not.
Yeah, no, but it does. The point is it is an interesting ethical discussion because there really are two sides to it. Because at the same time, so let's say a kid goes into the store the day after Nick hit the store and wiped them out of all the packs that had good cards in it. So now this kid's buying this pack expecting that, there's at least a chance I'm going to get something good, where there's really no chance. Because all the packs that had good stuff in it are gone.
That's okay. You should learn that early in life.
You see what I'm saying? So there's some evidence there. But in any case, the reason I thought about it is I wonder then if the phone is sensitive enough to be able to tell the difference between those things.
I don't know about card packs. I don't know what the weight
but certainly if you're selling flour on the street, it passes the what is the dime bag test? What's the? I don't.
To the next one.
You're proving the weight on your phone.
Welcome to iOS 9.0 and the iPhone 6s, where drug dealing becomes much easier. Don't get arrested for having that scale in your pocket.
That's right.
Just carry your new iPhone around.
All right, so let's keep trucking here. So, So in any case, let's see where we left off. Don't care about that. Certainly the concept of interrupting the CPU, that type of stuff. The different types of storage, volatile versus non-volatile memory, certainly fair game. Speed, the speed versus cost thing, fastest types of memory, slowest types of memory, kind of the trade-off as memory gets slower, it tends to also get bigger and more cost-effective per bit or something like that, depending on how you want to talk about it. So there's kind of that picture of that guy. Certainly dual core CPU stuff, but most of it would be from the second half where we kind of went back and revisited these high level things at a little bit lower level. All right. Thought that was the right. It is command. Oh, I get it. All right. I was thinking that meant right arrow, not the greater than sign when it told me what the thing was. The different types of caches and what they're used for. So this is mostly memory that, so I probably am not going to ask a whole lot of stuff about like the slower memory, but we certainly understand the differences between registers and the three caches as they relate to CPUs. So registers are right on the CPU. L1 cache is close. L2 cache is a little bit farther, but still on the CPUs. L3 sits outside of the CPU and is usually used for sharing data between CPUs. So kind of that that guy there. Let's see. Okay, that's fine. That's fine. You should be able to draw by hand to scale the Mac OS.
To scale? Which screen?
Well, I would give you a dots per inch.
Okay.
So generous.
Some of the stuff we're going to talk about here in a few minutes on the other side, so I'll just wait till those slides anyways. The concept of a microkernel, like what's the purpose? That idea of pulling all the really important stuff that is truly operating system dependent into this tiny kernel, and then having everything else sit as an abstraction layer above that. Where we have less stuff that has to kind of travel through. It's almost, if we relate it to things we've been talking about more recently, if we treat the kernel as kind of the critical section where dangerous things can happen, the smaller the kernel is, the less other things we have to have floating around in there. So the idea might be that less bad things can happen, or fewer bad things can happen. Certainly the idea of virtual machines, specifically from like a performance idea, where's the slowdown, sharing system resources. Again, this is almost another layer of the operating system problem, where we can split our CPUs up, we can split our RAM up, and that doesn't really give us a major performance issue with a virtual machine, because those are divisible resources. If you have 16 gigabytes of RAM and you split it in half and give 8 gigs to each to a virtual machine, that RAM is not now slower because it's divisible, as opposed to you can have multiple things hitting RAM at the same time. As I guess my point, you are putting some stress on the memory manager, but that's more at a software level than the hardware not being able to take it. So if we were thinking about the memory from a semaphore perspective, we would let plenty of people through the door to access the memory, independent of each other. Okay, which is really why more recently we've been talking about using semaphores to protect data from changing from too many different places because of this idea that we could have multiple guys changing something in memory at the same time. That's why we might need to protect certain parts of memory, but not memory as a whole. All right, so splitting memory up, or if you have 4 processors, giving 2 of them to a virtual machine, those are all fine. But the real slowdown is on the hard drive side of things. Hard drive is really something that needs to be protected, where we, only want to allow one thing to have access to the hard drive at a time, especially mechanical hard drives. That argument might change in the future now that we have solid state things, but these solid state drives today are still mimicking mechanical hard drives, just with different failure rates and things like that. So they keep getting faster and faster and faster as we learn how to fix that interface, or fix the ways that operating systems are talking to these guys, since they no longer have to talk to them as if they're a mechanical drive. So today we have non-mechanical solid state drives that are still being treated by the operating system as if they're a mechanical drive. Okay. Chapter 2. All right, so of course we should all know that that is a Dilophosaurus. That might be right, actually.
I'm going to be so happy if I walk in on the final and it's just a dinosaur test.
just pictures of dinosaurs. Was this a Stegosaurus? Is that what that is? Ooh.
Is that a raptor?
I don't think so. His neck is too curvy.
I can't tell what the one on the bottom.
Yeah, I think that's supposed to have spikes.
It's
just
like looking through his legs, like looking backwards through his legs or something.
Yeah, it's hard to say.
He's looking at the slide content.
Yeah, he is.
Oh, it's a velociraptor.
This guy up here?
It's a velociraptor. I don't know.
No, it's
that.
It's the curvy neck. Doesn't seem like. I think velociraptors look more like muscular up here. I ran into one at a Walmart once. All right. So let's. All right. So certainly the idea of a process, the idea of a PCB. We started talking about things in terms of the data structures that kind of make up our operating systems. This was kind of the part where we were writing our little simulator. So the idea of what a process is, the short-term queue, the long-term queue, or the scheduling queue and the CPU queue. Let's see. Kind of the parts of a process, but not in like crazy detail. I guess when I think about a process, I want you to kind of understand that the process contains the list of instructions that program is supposed to do, because actually it only contains some of those. We never actually got to talk about memory management, but just the high-level version of this is a PCB at any point in time is only going to hold on to a fraction of the instructions associated with a particular program. And what happens is if the inside those instructions, if it says go from here and jump down to another instruction, and that instruction is not available, the CPU interrupts itself and then requests that instruction be brought into memory from virtual memory. So we have virtual memory as this idea of duplicating or pretending like you have more memory than you physically do in your computer by using some of the hard drive space to fake memory. But hard drives are slow, memory is fast, kind of that thing. So the idea would be that the PCB for Microsoft Word is not going to contain the entire collection of instructions that Microsoft Word has. Has a subset, and somehow those things get pulled in when they're needed, we can say for right now. But understand that a process is going to hold instructions. It's going to hold the current program counter where we are in the code. The stack data section, this stuff is relatively unimportant. I want you to think about PCBs in terms of these things. Certainly process states, new, running, waiting, ready, terminated. Just that idea and what are, when is something in each of those situations. Certainly the idea of the CPU registers being stored inside the process control block and why, to support context switching. The various queues we discussed. Pacman. Just in general, Pacman.
Like the year was made, or
At the Pacman as a lifestyle. For extra credit, you have to do a Pac-Man impersonation. I showed you that in class, right? Did my Pac-Man. Can anybody else do one?
Yeah, remember YouTube
I think
took on the
everybody
video?
can do one. Just
No. It's important that it's realistic. Go up behind people. I do that. They think Pac-Man's coming. Wouldn't that make like a really funny? Actually, it sort of happened in the movies this last year, right? What was the name of that?
Pixels.
Yeah, I actually thought that was kind of a good movie. I liked it.
Is Adam Sandler, right?
Yeah, but it wasn't a normal Adam Sandler movie. It really wasn't. It really was not a normal Adam
I don't know
Sandler.
if I can trust you. I know
It
Adam
couldn't.
Sandler.
It could have easily just not had Adam Sandler in it. It didn't play the normal slapstick, stupid Adam Sandler stuff. It was actually kind of an interesting
I
movie.
saw a Futurama episode. I don't know if I need to watch the movie.
But the point I was going to make is, that would actually make kind of an interesting movie if Pac-Man was like a horror character, like Friday the 13th, but instead it was Pac-Man. You just he's just coming around the corner. You hear you have the mystery noises and stuff like that, and all of a sudden it's Abba, 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 Abba.
You say Abba, but I always thought it was Waka. Like Waka, 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 Waka.
No, I think that's the joke. Waka Waka is was it Fonzie from the Muppets, right? I think there's some group right now protesting the new Muppets movie that it's too violent.
TV show?
I think there's.
Is that a TV show?
It's a TV show. It's stupid.
No, but is that what they're protesting? Is it a
I
TV
don't
show?
know.
I think there's a new movie coming out. I think there's a new movie, a new Muppet.
It was something to do with. I think it was Kermit leaving Mrs. Piggy for like.
It's Miss Piggy.
Sorry.
They're not married.
Yeah, like
Christian worldview.
a skinnier version, and everybody was upset that he was leaving Mrs. Piggy because she was fat or something.
So a more aerodynamic Miss Piggy. I get it. This is a sports model. So people are complaining about that, about
That's what I think I remember.
About-
but I could be wrong.
Muppets.
you see my
That show
surprised
was
face.
controversial, like the very first episode of Muppets was called Sex and Violence.
I don't know, but I hope so.
What do you Google?
I didn't
Okay.
watch it.
No,
I
it's
gotta
something I
Google
know off
this.
the top of my head.
But the point is that we're talking about a show of puppets where we have frogs and pigs and talking bears, and reality's out the window. So it's like it doesn't really matter. Like how they date isn't really important. Okay, so again, Pac-Man. You should do the names of all the ghosts.
Red one, blue one.
No, they have names.
Blinky, Pinky, and Pink Pie.
Do you know the colors?
Yes.
That's right.
Oh my god. I gotta sit next to this guy on the That's
Oh,
okay.
it wasn't the first episode. It was the second episode that was called Sex and Violence.
All right, so big deal here is the idea of context switching. So context switching is really important for us. The idea of process creation, and in that same conversation would be threads. We have a whole chapter on threads. So that idea of a process versus a thread, how are they? Who's in charge of them? It's a process is born out of the CPU or out of another process, where a thread is born from a process itself and is managed by that process. And then we blurred those lines when we talked about, well, what if threads need to get more CPU time? How do threads actually how do we make them? How do we allow them to get scheduled by the system, the operating system itself? How do we let a thread that's supposed to live within a process leak into the operating system and act more like a process? So just that whole idea of the fork system call and multi-threading and all that stuff. Then interprocess communication, the various means by which our processes or even threads can talk with each other. So this would probably be, there will likely be at least a couple of questions dealing with this. I would say this concept is important. So now we have all these different processes running concurrently on our system, whether it's a process or whether it's a thread. Doesn't matter in this context, but these guys might need to talk to each other. How do we provide communication mechanisms between these kind of foreign entities, if you will? So one thing we talked about is, more modernly, we've talked about in our programming languages using things like singletons, where we have kind of a shared memory between multiple processes. So we have that equivalent type thing in our operating system. So our operating system effectively allows us to generate a singleton. Generate a section of shared memory that multiple processes can kind of register with and say, I want to have access to this guy. So we can pass stuff that way. And all these were done in terms of this idea of this producer-consumer problem where one process produces something that other processes are interested in having, and the producer needs to be able to get its product, its information, to its consumers. That's the producer-consumer problem. It's just a generalistic idea. This process makes something, this process reads something. How does this guy get his stuff over here? All right, that's where we have some sort of cloudy type stuff within our operating system to provide these things. We talked about unbounded versus bounded buffers. I probably won't ask you anything about those specifically. It's pretty generic, right? Some of them are bound by a maximum size, some of them are not. Okay, it doesn't really matter for the idea of interprocess communication. Does have to do with how much we can read at a time, that kind of stuff, but not so important. That's more implementation specific as opposed to generalistically how do two processes talk. That's what we care more about, that we understand that concept that two processes can't just talk to each other like we're talking to each other. We require some sort of extra mechanism to do this.
Hey, have you seen, you haven't seen the third season of Arrow, have you? There's season 1 and 2 on Netflix, but there's a third season and they're currently in the fourth season.
Oh, I haven't.
So you need the third season too.
Is that a random number generator thing?
Is it alright if it outputs a .mkv or is because you stream it through your Apple TV,
Right.
and I don't think it's a .mkv.
Oh, .mpg or
MP4 is
MP4,
best, but I could.
That's fine.
I can convert.
Usually,
I mean, I have a random number generator. I have the discs for that too.
Oh,
But yeah.
Well, then you should just give them that.
Oh no, I mean I
don't have a DVD player.
I can turn.
How do you not have a DVD player?
Who has a DVD player in the now everybody streams?
No.
Well, yeah,
Over.
but I mean, come on. For
Take
the past
my
like 5
discs,
years, you don't
put
have a
them into
Blu-ray?
your awesome random number generator, and I'm sure somehow we can get MP4 files.
Well, yeah, you can just use Handbrake. That's the.
Well, I'm not going to hook that up to a TV.
Oh, no.
With my Xbox members. That's what my Xbox is.
All right, yeah. Any DVD players I've had have been in Xboxes
Handbrake it,
or
you
a
got the
PS4.
DVD, and then there you go.
That's smart.
It's brilliant.
Although my dad still has
And then you have a
VHS.
dick who replaces the DVD with the paper copy of it.
Plus, I'd be very upset if I was in the hot tub and an episode ended and it was at the end of the disc, so I had to switch to a different disc.
Yeah, and then the next guy goes.
Well, right now Netflix just automatically plays the next episode. I don't even have to move.
But it does ask you, do you want to continue watching?
Only after about 6 episodes.
Really? Mine does it after like 3. I think it knows that I've spent too much time.
Oh, well, maybe it is. Maybe it's 3, but whatever it is.
Like, I do this.
At that point, if I'm still in the hot tub after 3 episodes, the body temperature, I'm probably dead. That's, I guess, the thing. But, yeah, no, I don't want DVDs. I want randomly generated
MP4.
MP4s. It's like, Now, actually, that becomes another interesting ethical question as well, and I guess ethical computing is I pay for cable, so every one of those shows
You could have.
would have I have been paying it for years and years and years, so it would have been on my TV.
Wait, don't you have Time Warner? You know through their app.
No, I have
Oh,
Uverse.
Okay, I was
I have
about to say,
Uverse.
well, Uverse I think has it too. They have an app where you can download it and then go back and watch those.
The on-demand only goes back so far.
Oh,
But regardless, the idea is, so is it then, if I've paid for that content and never stopped paying for that content, just because I didn't record it, just because I forgot to record it, let's say, is it then?
oh, it's still illegal.
But should it be?
Yeah.
Yeah, I mean, from an ethical, that becomes another one of those interesting questions, right?
I would say that is, in that case, absolutely you have a right to
Well, no,
maybe not
before
own
you
it, but
watch,
to at least watch it once.
Yeah.
From a
Even
moral
more-
standpoint, you should be able to watch that episode because you did pay for it. But
so
I also
watching
think
is
that
one thing.
ISPs
The
and
way you
cable companies make too
acquire
much
it's a
money
whole
anyways.
separate.
What's even more interesting idea is a library. You can get movies or TV shows or anything from a library. You just have to order it. But if it's online, I just treat
Oh,
it
I
as
gotcha.
a library.
Yeah. So you're taking my example to the next step. If you could obtain a library card,
Yeah.
then any of these shows you could go and just get from the library.
Yeah.
You just might have to wait for it, so it's not real time, right?
Well, I mean,
Like, who
it's
goes
possible. So
Yeah,
why
no,
not?
I get it. Yeah, I mean, those become very interesting things. I think technology has created this thing where it is blurred. It's another source of. I mean, maybe it should just be a tax, like a catch-all tax. Like there's just a media tax. There's no more cable bills. There's no more anything. Just there's a media tax.
Okay,
You would just
Bernie
have
Sanders and free
but the problem is
TV.
you would have the people who, mostly, I would say the older people who aren't going to be consuming. I would sit there and I would consume. I would make use of my media tax. But
Right.
My parents, my dad would watch a football game or something. He wouldn't use it. So I don't think you could get.
We're talking about we do it with
on that.
healthcare now.
It's a little bit different though.
No, it's the same philosophy. You're
It's
giving,
totally
you're
not.
having you're having the group pay
But
for a
entertainment
whole.
isn't a base need.
Well, no,
like
and I
healthcare
get it.
is.
So maybe it's not a tax. Maybe there's just instead of it being you pay for media
Well,
to a provider,
I think there
you
is a
pay for
solution.
media to a conglomerate of providers, and with that subscription, you get whatever.
I've,
Well,
like,
then you have a
basically
monopoly
stopped
on the market.
randomly generating music because of streaming services like Google Play. I don't need to
Yeah.
because it's all there. I
They
don't
just have to offer
Yeah, yeah.
the correct service.
Yeah, I totally agree. Like if I could
Same
just
with,
if I could just pay a monthly fee for just unlimited content, I and make it on demand easily, I would. I mean, that
Netflix has shown that. I think.
Yeah.
I mean,
yeah, and I would pay more. I mean, I'm not promoting it, but if Netflix was $30 a month, I would probably still pay it if it was $30 a month because of I use it all the time. So that would be worth it to me. When what is it, $8 a month or $9 a month, whatever it is. So they could triple their cost, their price. They probably wouldn't change their bottom line, would they? Because their bottom line would ultimately, they'd probably have the same amount of money coming in because they'd have, half of their consumer base drop off, and then the people who really use the service would just pay more.
Well, if you do that, then why don't you just buy the season on iTunes and automatically stream it for a
buying
show?
Because I've already
iTunes
paid for the
probably
content.
costs you like $200.
I've already paid for the content. If I hadn't, and instead was just buying pay as you go, that's that model, right? The pay as you go model where I want to watch this show, so I'll buy that show, and in the end, it's probably going to
But
come
in
out to about the
reality,
same.
You didn't pay for the content; you paid for access to it.
Right. But I'm still paying for access to it. At no point in there did I break I paid for access to the content for years and years and years.
Movie theater, though, in terms of your cable company, it's just like a movie theater.
Mhm.
You pay for access to a movie to watch it when you're there.
Fair
and when
enough.
it's on.
Fair enough, but those reruns are still playing.
Yeah.
So I'm still getting that access to it. So let's just say that my recording failed. I mean, you can create all sorts of blurry lines
Yeah.
with this. I mean,
It's definitely a blur.
it becomes very interesting, I think.
And I'm all for the random number.
Which is why we almost have to have a new model, because the idea of what's ethical is out the window, because you could argue your way out of almost any technology-based ethical question. You could come up with the gray area dark side to it and convince yourself of it, I guess. All right, so here, message passing. So one thing is we can directly send messages between two things with send and receives. Let's see. So that would be through our direct communication. Indirect communication becomes more of our singleton type thing. So they talk about, you can use a mailbox where, it's almost like a drop-off location like you watch in TV shows, right? They have the drop location. Somebody drops the stuff behind the dumpster on 3rd Street, and the person who wants it comes and gets it from the dumpster behind the dumpster on 3rd Street, whatever it is. Okay, so that would be our mailbox. Two guys know about this unique ID, the producer and the consumer, and they check to see if something's been dropped there. So that's the mailbox thing. More recently, we've been talking about synchronization, but we've been talking about it at a lower level. So we kind of been making multiple passes through these topics. Because now we have this idea. So in that mailbox example, what's synchronization? It's this idea that the consumer should not go and try to consume the data before the data has arrived, right? So that's one issue. And then the other issue is that also sharing. We've been talking more recently about sharing resources. Ten. So this idea of a socket connection. So this is typically we think about a socket as being a connection over the internet. So processes on multiple computers where we're connecting via IP address. There's no reason why you can't use a socket to locally have two processes talk to each other, where they would actually connect to the local IP address, which is masked through something called localhost on the actual operating system, but has a default. Most of our operating systems do it. It's 127.0.0.1 is the IP address of localhost. So you could technically open up a socket to either localhost or to 127.0.0.1, and it would open up a connection back to that same computer on a certain port that maybe that other process is listening on. So you could technically, kind of MacGyver this tool to do communication within the same computer. Now, there's actually a mechanism that existed before sockets. Sockets are an evolutionary step of something called a pipe. We have multiple pipes. We have pipes, unnamed pipes and named pipes. So a pipe specifically is for communication between things on the same computer. They don't make you take that step of, giving the address of where this thing is. So, and this essentially just is like making a phone call. It opens up a communication channel that you can send and receive stuff. You still need to now synchronize that communication channel to make sure data is there when you want to read it. And that kind of stuff. So there has to be that's why we pick some sort of protocol to send over that guy, so we know, we maybe say send, and we keep sending data until they finally send a done, something like that. So the other guy can start receiving data. He just keeps reading until he finally hits a done. The idea of remote procedure calls, these guys kind of died off. I probably talked about it in terms of Java had a technology for this, so I probably won't ask a question about remote procedure calls, where they were kind of a failure. But it's the idea of it effectively abstracts a socket by allowing you to make a function call that utilizes a socket in a specialized way to send some parameters, do some logic, and send a result back. That's what a remote procedure call is.
So those are or aren't used?
They're not used really anymore. Yeah, so it's a good idea, but they're just an implementation of sockets, and they never really took off.
So sockets are the go-to?
Sockets are the underlying technology and give you full flexibility to kind of do your own remote procedure call. So as far as an exam goes, sockets are definitely important. I won't ask anything about remote procedure calls. They're not, I guess.
We had a homework about like nothing but remote procedure calls.
Well, it's not that they're not important to understand them. I mean, because they do still exist. They're just not like a popular go-to move. In fact, if anything, they're making comebacks now through RESTful APIs, where we're seeing a program opening up a communication channel over the internet, talking to some endpoint, a remote procedure endpoint that takes in some parameters and spits back a result.
Or 390 or Twilio thing, would that be an RPC?
Yeah, because you're talking to their endpoints, which is, their more modern implementation of a remote procedure call built on top of the HTTP protocol, as opposed to this would be more of a proprietary special technology for doing it. Here's the pipes. Pipes are local sockets, let's say. The idea of duplex versus full duplex, if I get desperate for a question, maybe. So duplex, full duplex is communication both directions. Half duplex is only one way at a time.
It was just unnamed versus named.
Well, we have this guy right here for communication. Half duplex and full duplex they're not pipe specific. It's any sort of communication. But realistically, I don't even see myself asking. If I were going to ask questions from this section, I would probably focus on sockets. Sockets are the go-to guy, and you can use them as pipes. It's not a so sockets from that section. That's what's going to be a useful. All right, so we already kind of talked about the things that are important from this. The idea of threads, having multiple threads, the cost of a thread. So, there's a trade-off between a program spawning off a zillion threads versus having just a couple of threads because it has to share its CPU time. So there is a starvation issue there. Kernel threads versus user threads. That one-to-one, one-to-many, many-to-many type relationship this is that idea of scheduling outside how the operating system itself can schedule threads. I won't ask anything about specific thread libraries like pthreads or something like that. It'll be more threads in general. The idea of a thread versus a process. A thread is kind of a lightweight process. It doesn't have to have all the extra crap in it because it's not originally meant for being scheduled by the operating system. But then now we have to wrap it with some extra stuff to make it work. But I won't ask you about specific types of threads, like what's the difference between a P thread and a Win32 thread or something like that. It's a waste of time. All right, so now we kind of made another pass on our CPU scheduling stuff. I probably won't ask anything about preemptive versus non-preemptive. It's blurry anyways because most of our operating systems kind of do both. This idea of our different scheduling criteria, how do we choose who's next? Kind of the different options for that. CPU utilization, throughput, turnaround time, waiting time, response time, and all of those become gray areas in and of themselves because it's almost a guess as to what's the next thing. So you're almost taking statistics. So then some specific scheduling algorithms. So first come, first serve, certainly understand that. Pros and cons of that. Shortest job first. Pros and cons of that, presuming you actually know what the shortest job is. So if I asked you about pros and cons of that guy, one of the things you're going to bring up is, while shortest job first might make sense, knowing what the shortest job is problematic in and of itself. The idea of priority scheduling and how do we handle the problem of starvation through aging, where we bump the priority of things over time. Round robin, where we just kind of give everybody a little bit of CPU time and hope for the best. Multi-level queue is a fancy way of saying what we've been saying all along, where we have multiple queues to do stuff. Highest priority to lowest priority. Certainly some high-level topics dealing with what happens when we're scheduling on multiple processors. Making sure that, you know, some things can't happen before another thing happens. So when is something ready and which line does it get into and that kind of stuff. I would say more high-level ideas, problems specifically associated, you know, it's problems that multiple CPUs create. Nothing about specific scheduling. In fact, I think we're probably even a little past where there's Little's formula. Half the exam will be on this. I will not ask you about Little's formula. It will not make any appearance on the exam. All right. And then just the stuff we've talked about recently. I think we've only gotten a couple of, you know, maybe a quarter of the way into chapter 6 or something. It's just kind of a continuation of that stuff. All right, that makes sense. No programming. No programming on the exam. So it'll be all short answer, essay. It would be fair maybe for me to give you a small little program that talks about a concept here, maybe forking or something, but
Conversion question.
Conversion questions are fair game. But there would probably only be one. But even as I say it's fair game for me to give you a program, I probably won't. So I would expect there to be nothing related to programming on the exam. All right. I will see everybody on Monday.
So